Alright, hey guys, welcome back to another tutorial. This one is going to be the one you guys have been waiting for. It's the actual full tutorial on how to get the blueprint objective markers to fully work in conjunction with objectives that you set with the other blueprints that we worked on in the first tutorial. This one is going to focus on, mostly it's going to be the HUD, making sure that everything gets set correctly so that visually on the HUD you see the directional arrow show up, it points to where the objective marker is, and then from there past that we'll also set up, I'll show you how to get it so that your character or your player can add or remove their own kind of custom objectives, and how to make sure that updates correctly with the HUD. So as a warning, this tutorial is going to have a lot of geometry, a lot of trigonometry. Well, some of this I had to get some help from my roommate, so just a shout out to Joe Gone, my roommate here, helped me with some of the trigonometry that needed to take place. So it might get a little confusing. I'll try to go as slow as I can. I want to keep this relatively short as a tutorial, but as well at the beginning of the video there will be a list of all the topics that we're covering that you can jump right to if you just click on it. So if you don't want to watch this part but watch a later part, you can do that, or if you just want to watch this part, click on and you'll be here right now. So let's go ahead and get started. What we're first going to do is kind of talk about where we left off a little bit in terms of the HUD, because right now what we have is just the normal on-screen indicator of where the objective is. But if we turn off screen, we have no idea where the objective is until we turn back here. And right now it does measure distance and everything. It stays on screen. But again, if you turn off and on screen, you can't see it. So that's what we're going to work on. That's what we're going to actually take place here. So let's first clear out everything we have here. And by clear out, I just mean kind of move it away. And if you don't know what all this stuff is, just watch the previous tutorial. You'll know. You'll be caught up from there. I'm not going to cover everything right here since we talked about in the previous tutorial. What I am going to do real quick is take the final result of our append of where our objective is, and we're just going to set this as a variable. So promote to variable, and we're going to call this objective text. We're just going to plug this into the loop body. And then over here, we can leave this alone, but we could also just set it as that variable, just to keep things consistent. So in our draw text that we have here, we can just get the objective text, just plug it in. But we're going to leave everything else here alone for right now. What we're going to do first is set a bunch of conditions to determine whether or not the player, or the objective I should say, is on screen based on the player's rotation, where they're looking at, things of that nature. So what we need to do first is get a reference to our player pawn. So get player pawn. And then we want to get the control rotation. So get control rotation. And then we want to get our forward vector. Because what we're doing here first is getting the player's X rotation. So looking left and right and checking to see if our actual objective is within view. So that we got the forward vector. Now what we need to do is get the player pawn again. So we can just copy this and get its location. So get actor location. And the last thing we need is the objective's location. So it's going to be the array element. So we can drag out of the array element, and the current objective array element is being set here. And we can get the actor location. And what we need to do first is subtract the player's location and the actor location of our objective. We need to subtract them and normalize that. So grab and normalize from the result. And then from here, we get the product of the normalize, and we need to get the dot product between the forward vector of our player and the normalized vector of the difference between our player location and our objective location. So let's just grab out here, taking dot, we'll get dot product, and it returns a float value. And we can print this out. So let's do a print. And we can plug in the float to this print, just to see the numbers that we're getting. Right now, obviously, our objective is not being drawn because we have it unplugged. So we can plug it back in just so we can visually see it. So there's our objective here. So now, once we turn away to the left, we get a value of negative 0.56. But, you can play around with this. So basically, a negative 0.66 is the number that I want. That's just as it's going off screen, if you notice. Right about here, we get about 0.65, 0.66. You can play around with this number, see exactly when you want this arrow to kind of take effect. So what I know is at a negative 0.66 value, I know my objective is off screen. And then if we move this direction, it's the same idea. It's negative 0.66. So that's the value that we're working with there. And so what we want to have is a conditional check to see if that number is true at this point, if we're at those 0.66 values. So this is where it starts getting a little bit confusing. But just stick with me. So what we're going to do, we're going to pull from here, we're going to do a greater than check. First we're going to check if it's greater than 0. So we're going to branch that out. But we're also going to check if the number is less than or equal to, and then for me, negative 0.66 is the number I want. Let's branch out from here. And what we're going to do, we're from this objective text, we're first going to check if it's greater than 0. Because if it is, we don't even want to check if it's negative 0.66, because obviously negative 0.66 is less than 0. So if this is false, that's when we want to check this condition. And then it's basically from this true and this true and false that we're going to do another set of conditions as well. So the next set of conditions that we're going to do is going to be to see if our objective is on screen in terms of the y-axis. So in order to check this, what we're going to need again is the actual location of our objective. So let's pull from the for each here in the array element. We do get actor location. And then we need to get our player controller, because what we're going to do is use our screen space to determine whether or not the actual object is on our screen in the Y position. So from our player controller, let's pull from that and then type in project world location to widget position. And it's going to need a world location. So we're going to use the actor location of our objective as the world location. Now we're going to right click on the screen position output, because right now it's a 2D position. We want to split that so we have X and Y. And again, we're only going to work with the Y position here. And what we need to compare it to is both 0 as well as our Y viewport size. And that will obviously change depending on how we're playing the game. So we need to get a reference to our viewport size. So let's do type in get viewport size. Break this guy up into X and Y individually. And now, this is where we need to check to see if it's greater than 0 or less than or equal to our Y screen space. So what we can do is grab this Y, do greater than, let's give it 0. And then we can grab from it again, and then see if it's less than or equal to our screen port Y. In this scenario, I do have a buffer that I want to create here. So let's create a new variable. We're going to call this Y position buffer. It's going to be a float. And we won't make this public or anything, it's not necessary. But I'm going to set its value to 400. And what I'm going to do with this, I'm going to get our Y screen size, add the buffer to it, and then do the comparison. So right now I'm asking, hey, is the Y position of our object projected on our screen space, is that less than or equal to our size of our screen space plus 400? It's just a number I liked and I found useful and working best for me. You can play with that number depending on what you want, but it was a number that worked best for me. And what we want to see is if both these conditions are true. So we want to have an AND Boolean. We're putting these both in and then branching from it. And what we're going to plug in is the true from our x here. So this bottom one here, we're going to put true into here. And then the true from this is where we're going to put back into our main objective drawing that we're doing before. So basically, as long as those conditions are met, we're going to be drawing. So as you can see, it disappears right at that point at the bottom. See there, not there. The same thing goes here when it gets to 0. Like you can't tell, but when it's off screen, based on the parameters we gave it, we're not drawing this objective marker anymore. So that's what this is what these checks are doing. Seeing if the objective is on screen or not. And if it is on screen, that's when we're drawing back the text where it's telling us, how far the objective is, as well as drawing that that HUD element, that material or texture, depending on what you're doing. So now, the last thing we need to do is another dot product here. This dot product is going to tell us whether or not the player is, looking at the objective, and by that I mean, if it's within a 180 radius, or if the player is actually like fully looking behind it, or facing completely away from it. I'll kind of show you what I mean. So again, for this check, we're going to need to get our player pawn. And then we're going to need to grab the actor location. Well, in all honesty, it's going to be the same, almost the same information that we have over here, except it's a little different. So again, let me get the player pawn. Get its actor location. Let me copy this get player pawn. And then from here we're going to get actor forward vector. And then we're going to need to grab our objective. So again, we're pulling from the array element. Get actor location. We're going to subtract the player location and our objective location. And instead, we're not going to normalize it now. That's something that's going to be different. All we're going to do now is get the dot product between these two. So the result of our subtraction and our forward vector. And again, just to show you, the number that we're going to get, we're going to do a print. Plug that into our print. And then the true results here and the false results here, as well as the false results here. It's going to go into our print. And we're going to get either a positive or negative number. So right now we have a negative, and now it's going positive, and then it's negative. So basically in the initial 180 degrees that we have, so like up to this point about, and then up to this point about, we have negative numbers. So this range of direction is negative, and then this range of direction is positive. So we know if that number is positive, the player is kind of looking away from the objective, like completely. The set of 180 degrees is now different, essentially. So that's what this number is dictating and telling us. So what we want to tell is if this number is greater than or equal to 0. So let's do greater than or equal. Actually, let's just do greater than 0. Just a second here. And then from here, we're going to do a branch. What we're connecting to it, again, is the true result of this number being greater than 0. The false result of this number being less than or equal to negative 0.66. And then the false result of this number, of this Boolean being true or false, so whether or not we're looking at the objective on our screen space in the Y. So now, we can just do a final print. We could just type in, objective. Actually, we don't need to print anything just yet. So at this point, our conditions are done. So again, our conditions are checking to see whether or not the objective is on our screen in terms of the X position. And that's why we're doing the control rotation, the forward vector, normalizing the location between the actor, the objective, I should say, and the player location. And then checking to see if it's less than or equal to 0.66, because that's the best number I saw during that check that we did earlier. And then seeing if it's greater than 0. And then checking this number being positive or negative. We kind of just talked about that. So this tells us whether or not the player is actually kind of facing towards the objective in terms of like the two different 180 degrees that exist in a 360 degree. So the 180 that's positive and then the 180 that's negative. And then lastly, we have the check to see whether or not the objective is on our screen space in terms of the Y position. And if everything, returns, true in terms of these two conditions here, we then tell our objective marker to draw in terms of like the normal one, not the directional arrow that we're going to be working on next. So that's the first part. Now the second part is where it does get tricky and it gets confusing. This is where I needed a lot of the help myself. So I might have a little trouble explaining kind of what we're doing. So just, I guess, follow along. Don't ask questions at this point. But this is where it gets to trigonometry. So, to start, we're gonna go all the way over here. Let's get to some empty space here. What we're first gonna do is get our viewport size and break up this structural pin. Actually, no. This is what we'll do. We'll get the viewport size. We're going to divide it by 2 because we want the half screen size. Essentially, is all we want. We want to know where the center. This is what will tell us where the center of our screen is. And next, what we need to do is get our objective's location. So we need to drag from this guy, get his actor location, and then we're going to use a cool function called project. And what this does is it takes its 3D location and projects it to our HUD and gives us its HUD location. We then need to convert this to a vector 2D. And now what we need to do is subtract these guys. So we're going to subtract, so the viewport size is going to be the top option, and then our vector, our position here is going to be the bottom. And then we're going to normalize this guy. And now at the same time, what we're going to do is grab our project here and our conversion to a 2D. We're going to break this vector. And then from here, we're going to get our viewport size again. Now we're going to split its structural pin. Divide the Y by 2, because we want to get half screen height. Now subtract these guys. And then check if this result is less than or equal to 0. And then do a branch. And now what we're going to do is the true result of this condition that we have over here is going to go into the new branch we just created. So again, the true result telling us whether or not that direction is positive or negative. So we're going to set up the branch up here. And now what we're going to do is the trigonometry portion of this. And again, this is where it's going to get confusing, so I apologize. I'm trying to explain as best as I can. Trigonometry is not my strong suit. But what we're going to do, let's just first move these guys on top. So now with this normalized 2D, we're going to split its structural pins so we get the x and y. And what we're going to first do is grab its x, multiplied by -1. And then we're going to take the a cosine in degrees, and then subtract 90 from it. And then this result is then going to turn into our rotation of our arrow. So in order to get this going, you need to draw a material. And we need to tell what material to draw. So let's go to our materials. And I created a directional arrow. And it works the same exact way that we set the objective marker rate, except it's an arrow. So this is the material for it. We're not going to go into too much detail about this. But that's our arrow. That's our arrow material. So we're going to set that to draw. And we're also going to plug in the false from this Boolean check here into this draw material. And then the negative -90, the result here, is going into our rotation. Our pivot is going to be the center of our material, so 0.5, 0.5. Scale position is going to remain false. The scale is best at 0.2 for me. The U width and the U height is going to be 1 and 1. The material U and the material V, I set that to 1024 by 1024. Screen width and screen height, set that to 128 and 128. So now what's more important here is the screen X and the screen Y. So basically telling this arrow where to draw. Because right now, it's going to be drawing in the top left corner. And we don't want that. We kind of want to draw it in a circle. So to do that, what we need to do, again, this is going to be where trigonometry comes into play, is from this a cosine, let me first push this guy back. So the result of this a cosine, what we're going to do is get just the cosine in degrees, and we're also going to get the sine in degrees. And now we need to create a new variable. It's going to be a float. We're going to call it the circle radius. So this is basically telling us, in how big of a circle is the arrow going to be drawn in. So you can make it like a really tight circle, or you can make it a very big circle. As the objective is, as the plate is turning and where the direction of the objective is, the arrow is going to follow that circle accordingly. So the default setting that I have for my circle is 500. So again, you can make this as big or as small as you want. It just depends on your screen size, pretty much. So what we're going to do here, we'll start with the cosine. What we're going to do is multiply. And we're going to add a pin, so we're multiplying three things together. One value is going to be -1. The other value is going to be our circle radius. And now, from our sine, what we're going to need here first is our viewport size. split this guy up and divide each one by 2. Or I should say, let's divide this by 2. Oops, by 2. And write this result. And what we're going to do with this result over here is add. What we're going to add to it is our half screen height. And then this result then goes into our screen X. Now for our screen Y, what we're going to do is take this sign, do another multiplication. We're going to multiply 3 different things here. First it's going to be -1, and then our circle radius, just like we did before. Then what we're going to add to this is half our screen Y. And what I'm going to do here is I'm going to clamp this value just so this radius doesn't go off screen. Because again, this is Y. So we're going to do a clamp. Minimum, I'm going to put it as 50. And then for the max, I'm going to get the viewport size again, split the structural pins, we get X and Y individually. And the max is going to be our Y screen minus 50. And this end value is then going to be our screen Y position. Now, the last few things that we could do here is going to be to draw our objective text as well. So down here, let's just copy and paste this draw text option. Set its text to the objective text that we have here. Now this is where it gets not confusing, but this is where we have to set up special parameters for its position. Now for the screen X, what we're going to do is get the results of this addition here that we're plugging into our X screen position for our arrow material. We're going to grab that, and we're going to do an add. This is where we're going to create a new variable. We're going to call this X position text buffer. We're going to set this to -25. We're going to plug this in to this plus, and then we're going to plug that into screen X, and we're going to do the same thing for the Y position. So let's create a new variable called Y position text buffer. This one's going to be -20 as its value. So let's copy and paste this. Take out the X position, put it in the Y position buffer. Plug this into the screen Y. And then last but not least, we need to take the clamped value that we have down here, plug that into the add, and that's all plugged in. So right now, what we have set up is a specific instance of degrees and direction for when our arrow is set to show up. So right now we have to find it. So right there is where it starts. This is the degrees that we have set up right now. Right now it's not a lot. So we need to continue working on this. And this is, again, going to get confusing because we're going to need to do these 3 more times with different types of angles. So what we need to do now is from this normalized 2D, we're going to need to do another multiplication of a -1. Get the A cosine. Now we need a minus 270 degrees. And then what we're going to do now is, again, multiply it by -1. It might seem redundant. I don't want to troubleshoot and change anything, so we're just going to put it as it is and as it works. So now the result with this -1 here is where we're going to copy and paste the draw material. And this is going to be our rotation. And what's going to be drawn what we're going to do here is now the true in this branch is going to be plugged into this. And now we need to set up the X and Y position. So to do that, to get this position, we're going to do what we kind of did before. Get the cosine and the sine of this result. So this math right here, involving the circle radius, the cosine and sine of the degree, it's all going back here. And so the a cosine is being plugged here, a cosine is getting plugged in here to the sine and cosine. Everything else stays the same. Now we can just plug in with the cosine, the x, and then the y from the clamp. And the same thing goes for drawing the text here. So plugging the value here that we're plugging into the screen x, into the buffer for text, then the clamp here. Let's see how we have everything set up. So this is what we have set up right now. We have this set. As soon as we reach a threshold, it kind of breaks and stops. So this is the threshold we have. So at this point, we need to finish the threshold that we need. So what we need to do is basically do what we just did, but 2 more times. And it's gonna be the math's gonna be similar. It's just gonna be just a tiny bit different. So what we need to do is from this false, and again this false is telling us whether or not the number is positive or not, we need to do another set of checks. So let us move these guys up. And now the check that we're going to need to make is the y position. It's a conditional check to see if the objective's projected y location subtracted by half of the screen height is less than or equal to 0. So that's what we're going to be checking for. So what we need to do is get the array element, the objective, get the active location, and then do a project, and then convert this to 2D. And we're going to be using this 2D to then again, set up the rotation, screen X and screen Y of our arrow. But for our condition, what we're going to need is to get our viewport size. And we're going to split this up, get its Y and divide it by 2, just so we get half the screen height. And then what we're going to do is we're going to break this vector 2D that we got from our projected screen location for our objective. And we're going to subtract that by half our screen height. And then we're going to check this result to see if it's less than or equal to 0. do a branch. And again, the false that we have at the start here to tell us whether or not, the direction we're facing is positive or negative. Grab that false, plug it into this branch. Let's move these guys down. And now, if this is false, that's where we're going to draw a certain material here. But before we do the draw material, let's actually grab that real quick. Let's do draw material. Plug in the false here. Now, to get its rotation, it's going to be similar to what we did earlier. So what we're going to do, here is get our viewport size divided by 2. And then we're going to do a subtraction of this by our projected location of our objective. So again, we're subtracting half of our, or basically the center of our screen, we're subtracting that by the projected screen location, the 2D of our object here. And then we're going to normalize it. And now we're going to do -1, so times it by -1. Now get the A cosine. Oh, no, I'm sorry. So with the normalized 2D, we're going to break this split. We're going to split it up to x and y. So from the x, that's where we're going to times it by -1. Oops. And then we're going to get the A cosine in degrees. And then it's from here, we're going to minus 270. And then this result goes into our rotation. And now for the screen X and screen Y, it's going to be just like what we did before. So let's grab that and copy and paste it. So again, it's going to be these guys right here, the cosine and sine. We're just going to plug the result of the A cosine into the cosine, as well as the A cosine to the sine. And then the result of the multiplication with our circle radius through the cosine, that's going into our x like we did before. And then the multiplication of the sine with our circle radius is going into the y. And then last but not least, we want to draw our text along with our buffers here. So let's grab these guys. Put that in here. Plug in the result for our x up into the x buffer addition, and then the result of our clamp into the buffer here. So that's done. And then last but not least, we got to do this just one more time. So the last portion of it, so the true portion of it, let's grab another draw material, and we'll grab the text and everything. So let's put the true into this last draw material. So this one's just a little bit different than what we just did. Where we're going to get the result of the normalize. We're going to multiply it by -1. We're going to get the A cosine in degrees. Now, for the rotation, we're going to minus this by 90. And again, this is kind of redundant just because of the -1 multiplication we have here. I'm not getting rid of it just because I don't want to break anything, just in case. But what we're going to do from this 90 results is multiply it again by -1. Then this result goes into our rotation. And now for the screen X and screen Y, what we're going to do is take from the A cosine, we're going to multiply -1. And then from this result, we're going to get the cosine. We're also going to get the sine. From the cosine, what we're going to do is multiply it by our circle radius. And then from here, we're going to add. And like what we did before, we're going to add half the screen width. So we get the viewport size divided by 2, get the x and y, plug in the x, and then this result goes into the screen x, and it also goes into our addition to our x position text buffer for our objective. Now for our y, we take our sine, we multiply that by our circle radius again. And then we add to that half our screen height, and then we clamp that value to 50, and then the screen height minus 50. Plug that into screen Y, and then also plug that in to our buffer. So that's it. So that's all of it combined. So let's see if this works. So if we move down, there's our arrow, and it's moving. And that's pretty much it. So we got it working. And then we move down, it's there. Move up, it's there. So the only thing that's kind of off right now is, like right now, with it being off on the right, we want it to be, the arrow to be on the right side, and the one's on the left. We want it to be on the left side. So we'll need to look back in to correct that. But that's going to come from I'm not too sure where that would be coming from, but that's something you guys can actually kind of look into if you want to change that. It's definitely going to be in with the, the screen X and screen Y. It might be these negative multiplications that we're doing right now. Let's see if that fixed it. Let's see. Now we could just kind of play around with it though. So right now I'm just trying to play around with the negative numbers here. See if I get any changes. There we go. So yeah, we just had to play around with some of those negative numbers. So we got that working. The only thing that's weird now is when we're facing, completely behind it. So again, it's negative when we're looking at it. So basically down here. So when it's false, this is when pretty much we would want those negative numbers back. So let's do -1 and -1. Or, no, I could be wrong. Let's make this one and make this one. No, let's get these guys negative again. Yeah, and again, I told you guys this would get confusing. So we're going to definitely do a recap of everything in just a minute here once I get the values right. That's right. Okay. So that's how I want it. So again, as a recap, to go over everything one more time now that everything's done, what we do, obviously we get our objective text, we set everything up. This is all that we did on the first tutorial. Past that, we start doing our checks. The first check that we do basically tells us whether or not the player rotation, the way the player is rotating, if the actual objective is on screen or not within the X directional axis, so left and right. To do that, we get our player pawn, we get the player's control rotation, and we get the forward vector. And we do a dot product between that and the normalized value of the subtraction between the player's location and our objective's location. That number is a float value that we want to see if it's greater than 0 or if it's less than or equal to -0.66. And that -0.66 number is an objective number. This is a number that I liked. We kind of showed what that number represented during the time we went over this portion. So whatever float value you want, set that number as that. Now basically, when we set our objective text, past that, we first do a branch to check to see if this value is greater than 0. If it's not, we then check to see if this number is less than or equal to -0.66. If it is less than or equal to -0.66, what we then do is check to see if the actual player or the objective's location is located on the Y. And how we do that is we get the objective's location, we use the project world location widget position by getting the player controller and then using the actor's location as the world location. And to check to see if it's on our screen in the Y position, we want to see if it's greater than 0 and to see if it's less than or equal to the value of our Y viewport size. And I do have a Y position buffer of 400, so you can do with or without that. So that's an AND condition. So if both of these are set to true, that basically tells us that we just want to draw our objective marker like normal. We don't want to draw any directional arrow. If it's set to false, that's when we want to check this number, and this number gives us a positive or negative value, depending on whether or not the player is actually facing in kind of the same relative direction as the objective. And we also plug in the false value of whether or not this is less than or equal to 0.66, because at that point we know that at this point we need to draw that there. And we also grab the true value if this is greater than 0. All that goes into this check. And so if the numbers is greater than 0, we know the number is positive, which means we're facing away. So that's when we do this drawing of our directional arrow and our objective text. So the first thing we do from here, we see if we have a condition to check whether or not the Y. It's a conditional check to see if the objective's projected Y location subtracted by half of the screen height is less than or equal to 0. And if it is, if it's true, Then we draw the arrow with this set of parameters in degrees. If it's false, we draw the material in the objective text with this set of parameters in degrees. And it all starts by getting the normalized 2D of the subtraction between our viewport size, so half our screen size, subtracted by our actors or objectives projected 2D location. And then we take the x value, negate it here by multiplying by -1. We get the a cosine in degrees, and then minus 90 from that set of degrees, and set that as the rotation. And then from there, we get the result of this a cosine. We get the cosine in degrees of that, negate it, multiply it by our circle radius, and then add half of our screen x position, and then add that to our screen x for our material. And then we also add it with the x position text buffer to draw our text slightly above the marker. For the y, we get the result of the a cosine. I get the sine of that, negate it and multiply it by the circle radius, and then add half the screen height, and then clamp that value so it doesn't go off screen, and then take that value and put it into our screen y, and then we also add it to our y position text buffer, and add that to the screen y for drawing our text. And that's for the false value here. For the true value, we get the x value here of the normalized 2D. We negate it again. We get the a cosine, we minus 270 degrees, and then we negate it again and set that to the rotation. And then from the a cosine, again, we do the same thing as we did before. We get the cosine in degrees, we negate it and multiply it by our circle radius, and then add half the screen width, and set that to the screen x for this material, and as well as adding that to our text buffer, and then setting that to our screen x position for our objective text. And then next, we get the sine of this a cosine, we get the sine here, negate it, multiply it by our circle radius, add half our screen height, clamp its value so it doesn't go off screen, set that value to our screen y for our arrow material, and then we also add that to our y position text buffer and set that as our screen position for our text. And we kind of do the same thing down here. So again, we do the same set of conditional checks here as we did above, where we check to see if the objective's projected y location subtracted by half of the screen height is greater than or less than, less than or equal to 0. And we also get the normalized here. So what we first do is negate the x, get the a cosine minus 270 degrees, and set that to our rotation. And again, this branch that we have up here is for the false up here. So again, whether or not the number that we have when we're turning is not positive or negative, that tells us if we're facing in the same direction as our objective. So if that's false, and if this condition is false as well, we draw the material using these set of parameters here. So again, we take the normalized subtraction vector between our projected objectives location as well as half our screen or center of our screen here. We negate it, get the a cosine minus 270 degrees, set that to our rotation. And then for position, we take from the a cosine and we get the cosine from that. We multiply by 1. We can actually take this pin out if we really wanted to. So now that we're just technically multiplying by our circle radius, and then add to that half our screen width, plug that into screen x, also plug it into our x position text buffer addition here, and set that screen x position for our drawing text, for our objective text. And then for the y, we get the a cosine, get the sine from that, multiply it by the circle radius, add half the screen height, clamp its value so it doesn't go off screen, put that position into our screen y for our arrow material, and also take that returned value, add it to our y position text buffer, and set that to our screen y for our drawing text for our objective text. And now if this is true, we then go down here. We get the return value x over normalized. We multiply it by -1. We get the so we get the a cosine from that minus 90. Multiply it by -1. Plug that into our rotation for our final drawn material. And then for our actual positions, we get the a cosine multiplied by -1. Get the cosine from that. Multiply it by our circle radius. add half the screen X, plug this result into the screen X for our draw material, also plug in the result of that into our addition to our X position text buffer, plug that into our screen X for our objective text location, and then for our Y, the result of this -1, we get the sign, multiply it by our circle radius, add half the screen height, clamp it so it doesn't go off screen, get the result, plug it into our screen Y for our draw material, and also plug in this result to the Y position text buffer, and then add that to our text position Y. So that's the whole thing. It's a little messy, so hopefully you guys understood. Definitely kind of watch the video a couple of times to understand it. So that's the main bulk of this tutorial. And again, our result is this. Something like that. And now what we would want to do, just for a little added, I guess, fun, quote unquote, is to kind of give the player the ability to add and add their own or remove the actual objectives, so they can kind of add their own, do what they want, and actually have our HUD recognize that. So give me a second here. I just got to pull up some other blueprints here as reference. Okay. So it's going to be in a character class. So what we're going to do is just right-click, do a new blueprint class, do a character, name this whatever you want. I'm going to call this BP objectives tutorial underscore character. What else I'm going to do here is just in our world settings, the default pawn class, I'm going to set this to BP objectives tutorial character. So it's not going to give us a lot. Actually, what we're going to do instead, it's not created from scratch. Let's grab the first person blueprint and let's create a copy of him. And then just rename this copy. Just name it BP objectives tutorial underscore character. I can add to my game mode here. Default pawn class, our tutorial's character. So now if we play, we have that ability. So now what we're going to do, let's open up our character that we just made. Let me also open up the one I have just as a reference point. What we're first going to do is just take off the ability to fire the weapon. We don't want that. And now what we're going to do, we're going to implement the use of the left and right mouse buttons. So let's first type in left mouse button. And first, how we're going to determine if the player is clicking on an actor that they can add to the objectives array. We're going to set a line trace. So to do that, let's first get a reference to our camera, the first person camera. We're going to get its world location. And we're also going to get its world rotation. Get world rotation. We're going to get its forward vector. And then we're going to multiply it by an objective number. It's going to be a float. And this number is going to determine how far in front the line trace is going to go. So 1500 units is fine for me. And then we're going to get a reference to our line trace by channel. So left mouse button, we're going to plug that in. Its start position is going to be the world location of our camera. The end position is going to be the addition of our camera's world location. And we're going to add that with the forward vector multiplied by the objective float number. That's going to be our end. So it's going to start from us and then end 1500 units away. So next what we need to do is break this hit result. And then what else we need to do is go into our construction script. And we need to get a reference to our objectives list. So get all actors of class. Do a get from this out actors array output, and then promote to variable. And we're going to call this objectives list. And then the actor class we're going to choose is the marker. So the one that we have here is called BP underscore objective. So now that we have that variable, what we now can do is grab that and then get, and it's going to be a variable within that blueprint class. Let's open up that app real quick. BP objective. So it has an array called objective. So far it's not referencing it. Might be because I set that too early. So let's do a get, and then promote this to variable, and call this objective marker reference instead. And now we should be able to grab the objective marker reference and grab objective. So get objective. So now we have a list of our objectives. So what we can do here first is just do a branch. And what our condition is going to be is the hit actor from this break hit result. First, we're going to check to see if it's not equal to none. And to set it to none, you're just going to leave this default value where it says select asset. We're going to plug that into the branch. And then we're going to do another branch from the true. So we're going to do branch. Now this condition, what we're going to do, we're going to grab the objective list. We're going to do a contains item. And we're going to put the hit actor into here. So we're going to check to see if this actor is already in an array. And then last but not least, what we're going to need to do is create a new variable. We're going to call this player added objectives. It's going to be an array. And it's going to be an actor array, so we got to get the actor variable type. And so if it doesn't contain it, this false value, that's where we're going to do an add. The array we're going to add it to is the player added objectives. The object that we're going to add is the hit actor. And then what else we're going to do is get a reference here to our objectives and the array objective. We're going to do another add. We're going to add the hit actor to that array as well. We're going to plug that in here. And then last but not least, we're going to get our play controller. We're going to reference to our HUD, so get HUD. And then from here, we're going to do set objectives. And because I have two different types of blueprints, I need to make sure I know which one I'm plugging this into. So it's going to be set HUD interface, the top one for me. And the objective list that we're going to plug in is the one that we have right here. The one with the objective marker reference. So now if we compile and go in, you can click on the actor, and it appears on screen. And what's cool too is, it handles multiple objectives. So now we need to set it up so we can remove these objects as well. We're going to use the right mouse button to determine that. So let's right click the right mouse button. And we're going to do a lot of copying and pasting here. So we're just going to copy all this. Make sure you don't miss anything here. And then the right mouse button is going to get plugged into the line trace. And now the only thing we're going to change is going to be, instead of adding, we're going to remove them. So at this point, if this is true, what we're going to do is just get our objective. We're going to do a remove item. It's going to be our hit actor. That's going to get plugged in. And then we're also going to do the same thing for our player added objectives. We're going to do a remove. Plug in the hit actor to check. Plug that in here. And then last but not least, we're going to do the set objectives with our player controller and our HUD reference. And the objective that we're plugging in here is going to be the one from our objective marker reference. And we can just plug that in. So we can left click, and then we can also right click, and we can also right click on existing ones. So right click, left click. We get added, and everything works as expected, which is awesome. So that's pretty much it for the tutorial itself. One last thing that we can really do. I'm not 100% sure if I showed you this. But the BP objective marker. I created a volume for this. That just basically allows you to add and remove objectives. So I'm not going to show you how to make this from scratch. I'll just kind of go over this. So how it works, it's just the touch volume. And what it does, as soon as you touch it, it loops through basically a public variable called add objective. And what you do, I'll throw this into the level and show you kind of how the actor works. So how it works, honestly, you can scale this volume to whatever you want. And really how it works is you have a couple parameters. First, it takes in your objectives list based on the initializer that you have in your scene. It also has variables for adding objectives, so you would just add elements and then use this picker to point out actors in your scene that you want to add to the objective. You do the same thing with removing, so anything that you know you want to get removed, you just add that to the removed objectives. And then you have a boolean that just tells you, hey, do you want to clear all your objectives? If so, check that. And if it's true, when you touch the volume, all the objectives are going to be cleared out. And then there's another boolean check specifically for player added objectives. So if you only want to remove objectives the player has added, just check that. And when you touch the volume, all those player added objectives will be removed. And then any other removed objects that you want will be removed as well. So how it works is, when you touch the volume, it goes through any of the added objectives. So any objectives that you added, you'll add it to the objectives list here. Once it's done, you'll do the same thing for the remove. So anything you want to remove, it's going to remove from your objective list. Once that's done, we do a boolean check to see whether or not we want to clear the objectives. If we do, we clear the array out, we set the objectives back, and we set all these variables appropriately so that the objectives realize that they're all cleared. If this is set to false, this is when we do the special check for the add. So if we want to clear all added player objectives, what we do is we get a reference to our player, and we have that objective list that we created called player added objectives. We go through each element, we remove them, and then set the objective list here. Once this is done, we also clear the player added objectives list. And then if this is false, all we do is update then our set objectives. So with the add and remove, we do all that here. So that's pretty much it. So again, thanks for watching, guys. I know you guys have been really wanting this tutorial. So hopefully it's lived up to the hype. What I'm going to do now is just show you the final results here in game. So I'm just going to load up the preview map. We can play. So we start off the game. We have our objective here. And here's also the initializer I set, just so you can see it visually. So we can left click and add, right click and remove. And from here we can cross this volume. And now we have a new set of objectives. So we can walk around, and then we can go into this room, new set of objectives. And then walk into this room, we have a new set of objectives. And then in this room, we have another set of objectives. And then last but not least, we have this last objective here. And this is all done by these volumes. So right now, all these have the clear player added objectives, but you can set it so, like say for this one, we can set a clear objectives list. So now if you play, go to this volume, there's no objectives anymore. So the new ones aren't even set here. It just clears it out. And you can uncheck it. You can also uncheck clear player added objectives. So let's add an objective here. So now, if we go in, the added one is still there. But it did clear out the one I wanted removed. And as you can see in our remove objective list, it's this preview mesh right here. So that's all of it. Just let you know how this will go going forward. I plan on selling this blueprint on the marketplace. I have to go through Epic, of course, to see if it'll get approved, but that's my plan. I want to sell it for between $5 and $10, just so you guys can have all the necessary blueprints. What's going to be included is this preview environment that I built. It's going to include all these assets here, all these blueprints that I have here. That includes the game mode, the HUD, the objective marker initializer, the objective marker interface, the objective marker volume, our player controller, and our actual character. They'll include the materials that I made. They'll include the textures I made, and they'll include just a default mesh default plane mesh. So it's going to come with all that, everything you'll need for the working blueprint. So again, it's going to be sold for $5 to $10 if it's approved. But if you don't want to pay that, you can just follow the tutorial that I just made, as well as the first part, and that should get to you for free. As long as you follow my instructions correctly, you shouldn't really have a problem. The only thing you really miss out on is the materials I use, the textures I use, and things like that. But primarily, you'll have the blueprints, which is pretty much what matters. So keep an eye out on the marketplace in the next coming weeks. If you like this tutorial, please subscribe, like the video, share it. Let me know what your thoughts are in the comments. If you have any problems with the blueprint, just watch the video again. You probably missed something. One thing to know too, from what I've read, from what I know, the newest version of Unreal, version 4.9 or higher, it's broken where the HUD doesn't draw materials at all, from what I realized. So I'm using 4.8 for this tutorial. For 4.9 or higher, or until they fix the problem, you can use the texture instead of the material when drawing it on the HUD. The texture should work just fine, as long as it has opacity and everything like that. But for the time being, 4.8 is the version you want to use. So that's going to be it for this tutorial. Thanks again, guys, for watching. I'll see you on the next one. Hey guys, thanks so much for watching that tutorial. If you enjoyed the content, click on me or click on the subscribe button to subscribe to the Devin Level Design channel. On the right, there's some more videos for more blueprints, more Unreal Engine 4, cinematic stuff, and some videos to some Let's Plays that I've been doing recently, so definitely check those out. At the bottom of the screen, you'll have all my social media stuff, my Facebook, my Twitter, even Snapchat, Steam name, all that good stuff. So hit me up on social media. Let me know your thoughts on the channel. Let me know if you have any problems with any of these videos, any questions, anything I can help out with. Definitely let me know. I try to be open to you guys as much as I can. But again, thanks for watching, guys. I really do appreciate it, and I'll see you next time. Bye.